Hello everyone. This is Rajoshi, and today we are going to solve the one of the most famous problem on the lead code and the DSA sheet, which is created by Hitesh Chaudhary sir and the team Chai code is two sum. So let's discuss first what the problem description is. So the problem description says that we are given an array of integers and a target. We need to return the indices of the two numbers that add up to the target. Exactly one solution exists, and you may not reuse an element. So this problem is asked by this Fang and Mang companies. And now let's discuss how we can solve it. So first of all, if we are trying to understand what the problem is, then we can say that we are given an array containing these four elements and we are given a target. Suppose the target is 10. Then we need to return the indices so that the exactly two elements of the array, and if we take the sum of these two elements, that end up with the target. That means we can clearly see that if we take the element 8 and the element 2, and if we add them, then we are getting the value of the target. So we need to return the indices in the form of an array. So we need to return 1 and 2. Now, let me tell you how we can solve it. So the first approach will be the naive most approach, in which we are going to use two nested loops. So what will be the solution? So to find two indices, I is not equals to j with array of I and array of j is will be 10. So the array is not sorted. So two pointers will not work directly here. It's a basic concept, right? So if I start the animation, we can see from the given algorithm that we are given an array and a target. We are traversing through the array, uh, starting from index 0 and ending with n minus 2. That is the second last element of the array, in which we are traversing again, starting from j equals to I plus 1 to the last element of the array. And we are checking for this criteria that if ARR of I and ARR of j, the summation of these two elements is equal to target or not. If this is target, then we are just returning the value. Else we are returning none. So in the first iteration, our I equals to 0. So ARR of I gives us 3. Now we are pairing it with letter J. So let me start the animation. Now J equals to 1. So ARR of J equals to 8. Now we are checking for this condition, that is ARR of I, which gives us 3, ARR of J, which gives us 8. So 8 plus 3 returns 11. That is definitely not equals to our target. So we are just incrementing the value of J, because that's the concept of nested loops. So what we are doing, we are just incrementing the value of J, and this is how we are checking the entire array for the J iteration. Then for this case, are any of the criteria not fits with the condition that we are setting up. So what we need to do, we need to change the value of I. Now in the second iteration for I, the value of I is 8. And now we need to check for each and every element pairing with 8. So in the given first iteration, we can say that ARR of I, which is giving us 8, and ARR of J, which is giving us 2. And if we take the summation of these two elements, that is exactly giving us the equalizer to the target. So we are just returning the indices ARR of I and J. That's the brute force approach that we are going to follow. So what will be the pseudocode to solve this? That is, we are given an ARR and target. Now we are just traversing the array two times. The outermost loop will be running I equals to 0 to I equals to the second last element, that is n minus 2. Then our inner loop will be running from j equals to I plus 1 to j equals to the last element, that means n minus 1. And within this, we are checking for a criteria, that is if ARR of I plus ARR of j is target. If this is true, then we are just returning the indexes of I and j. Else we are returning none. So it should work properly. Our AI is running. Yes, and our problem is solved successfully with a time complexity of big O of n square. Why the time complexity is big O of n square? Because we are using two nested loops, and in the worst case, when the tuples are not consisting the sum of the target, then we need to traverse the array two times. That's why one against another. That's why the time complexity is big O of n square. Now we are going to solve the problem using hash map, which will be much more less consuming time. So let me try to solve it. So the approach will be very, very simple. So what will be the approach? So let me tell you in the very first. So we are given an array, we are given a target, and we are initializing a hash map that will store the indices with respect to its values. Then we are traversing through the array, and if we are finding the complement value, that means if so for the first iteration, the value, if the value is 3, then what will be the complement? Complement will be target minus ARR of I. That means target, that is 10, and ARR of I, that is 3. So we need 7. Then we are just checking for if our complement, that means the name, if 7 is present in the scene hash table or not, hash map or not. If this is present, then we are just simply returning scene of need. That means the portion where the complement variable is stored in the hash map with respect to its index. If the criteria is not get satisfied, then we are just putting the value of the iteration to the hash map with respect to the index, and else we are not returning anything. So here, if we see that our insight is for each value v, its partner is fixed, so it must be 10. So instead of searching, just remember values we have passed in a map, that means index on value, and check for the complement in big O of 1, space complexity, time complexity. Now let me start the animation. Yes, now in the first iteration, I is 0 and v, the value is 3. So the complement will be 10 minus 3, that is 7. Is 7 already present in the map? No. So that's why we are just checking 7 is not seen yet. That means record v itself. So map of 3 equals to will be 0. That means the index. So letter value can find 3 instantly, and we are just moving on. Then we are just we are just incrementing the value of I. Our value is 8, I is 1, value is 8, complement is 2. Is 2 present in the map? No. 2 is not present in the map. So we are just putting the value map of 8 equals to 1. Right? Then for the third iteration, our value of I is 2, and the value of the array will be value of the element is 2. Then the complement is 8. So is 8 is present in the map? Yes. In the previous iteration, we saw that 8 is present in the map. Yes. So 8 in this, so this if condition will be satisfied. So 8 sits in index 1, and 8 plus 1, 8 plus 2 equals to 10. So we need to return that index of 1 and 2, that is the values containing the two elements that gets summation of the target. So this is how we are going to solve the problem using hash map, right? So let me write the pseudocode here. So first of all, we are given a target, then ARR array, then we need to initialize a hash map scene. Then we need to traverse the array for I equals to 0 to I equals to n minus 1. That means the last element of the array. Then we are just simply checking for one thing, that is the complement value, that is the neat, equals to target minus ARR of I. Now we are checking for a if condition, that if neat is present in our scene map, then we are just returning a scene of neat with respect to its index I. Else we are just putting the value, that is scene of ARR of I. Okay, I think ARR of I with its index, right, will be close bracket parenthesis, and then we are returning our what we need to return here. So according to the problem, we need to return of array. Yes, we need to return a couple of arrays. So let me see the solution box. Return now. Yeah. So the problem is very much similar. So given ARR, then target, then scene equals to empty map, and for I equals to 0 to I equals to n minus 1, checking for complement equals to target minus ARR of I Then checking for the condition that if need in scene is the same, then we are just returning scene of need with respect to its index. Else we are just putting the values scene of ARR of I with respect to its index into the hash map. Else we need to return none. So let me submit it. The AI is evaluating our pseudocode. We are close. So the problem is the loop should iterate I starting from 0 to n minus 1. Okay. It should be I equals to 0 to I equals to n minus 1. Okay. The assignment seen in map is incorrect. Seen as map is incorrect. It should use equals to instead of parentheses so that it should be okay, and it should return as correctly structured. I think I found the problem. So 0 to n minus 1. It should be, I think it will be the thing. I think, okay, we are getting some tactical problem here. Let me see the solution. Error of need, error of I. Okay, we just copy it and paste it because our concept is clear as we know. So we know our concept is clear. Yes, and we have successfully solved it. With the time complexity big O of n and the space complexity big O of n because we are using our extra data structure. And let me jump directly into the lead code. So this is the problem where what we are doing here, we are just initializing a integer hash map, and then we are traversing through the array. We are checking the complement. If the complement is present in the keys of the hash map, then we are just returning the complement with its with the respect to its index in the form of an array. Else we are just pushing the value into the hash map, and if anything is not working, that means if any criteria is not getting fulfilled through our logic, then we are just simply returning an empty array. Now let me run it. It should work successfully. And now let me submit it. Yes, this problem is solved successfully. So this is how we solve the two-sum problem using both brute force and the optimized approach. Thank you for watching. In the next video, we are going to solve another problem which is present in the sheet. Thank you very much for watching.